Hey guys, welcome back to another science lesson, this time about the periodic table of the elements. Have you ever wondered about what that big chart is on your teacher's wall with all those elements and symbols and names and numbers? Well, today we're going to take a look at how we could read that and figure out what it all means. So, thanks for joining us and follow along as we learn about the periodic table. Let's see, as a quick review, everyone should be able to look at this segment of the periodic table and figure out the protons, neutrons, and electrons. Let me show you how simple that would be. When I'm looking at Mercury, the first thing I notice is this number here. The 80 represents the atomic number of Mercury. And remember, the atomic number is the number of protons in an atom. Protons are positive and electrons are negative. So we're going to have exactly 80 electrons in Mercury. Neutrons can be a little harder to figure out. We're going to take our protons plus our neutrons to get the mass. This number here is the mass. If I round 200.59 to 201 atomic mass units, all I need to do is subtract the 80 protons and get 121 neutrons in a nucleus of Mercury. If you're interested more in Mercury, which is this actual metal that's a liquid at room temperature, click on the video links and learn all about Mercury. So, your at-home work this week is to look at the periodic table scavenger hunt, which is in your packet, and then the atoms family work that's also in your packet. There's also a quiz you guys are doing that will be due next Wednesday. Before you take the quiz, make sure you've reviewed all of the other information and you know that you're pretty well ready to go ahead and get a good score on that quiz. So, open up your packet and let's find the notes about the periodic table. Remember, you're going to fill in the blue words. Feel free to pause the video if you need more time. The periodic table is basically a chart classifying all the known elements into groups based on the atomic number and other common characteristics. When I look at something in the periodic table, I'll be able to tell quite a bit of information just by where it's located in the table. Elements are pure materials made of one type of atom. To have an element, you're going to need billions of atoms so that you can actually see the material. Here are some examples of elements. The periodic table is organized into periods or rows across the table. The atoms in each period have something in common, and it's all about the electrons. Each row or period indicates the number of electron orbitals you would find. Let's do an example. Every atom in the first period here, which is just hydrogen and helium, have one electron orbital or one ring. Everything in the third row or third period has 3. As we go down, 4, 5, 6, all to 7. These two rows down here are actually a continuation of the periodic table's 6 and 7 row, so these are also 6 and 7 orbital rings. The periodic table is also grouped into groups, sometimes called families. These are the up and down columns in the periodic table. And just like family members are similar, the groups or families have similar characteristics. For example, all of these elements have one electron in their outermost electric orbital. The last group, 18, is also called the noble gases. They're all gases. None of them interact with other atoms, thus the term noble gases. How do we read each of the squares in the periodic table? Let's take a look at an example. Here's krypton with atomic number 36. So you'll find it as number 36 in the periodic table. We have a symbol, a name, and the mass. Often the symbol looks a lot like the name, but in some elements like gold, the symbol is AU. That's because some of the elements were named after Latin or Greek or other types of languages that perhaps existed before even English was spoken. Let's look and figure out how we could get all of these answers from the periodic table. We know already the protons is the same as the atomic number. The mass is given as 83.8, which we'll round up to 84. The neutrons is simply subtracting those two numbers because protons plus neutrons equals the atomic mass. Remember, electrons are negative. We're going to balance the number of electrons with the number of protons. Now, the new things that we've just learned, let's find out what period it's in. That means what row across. 1, 2, 3, 4. It looks like the gas krypton is in the 4th row, the 4th period. That means it has 4 orbital rings. The last thing to look at is the group number. In this case, we can count over 1, 2, 3. We'd get 18 as a group number. But this one has its own special name, so let's put that down too. Noble gases. So, some review, things to know. The atomic number is always the number of protons, or the positive particles in the nucleus. The mass is always the number of protons plus neutrons in the nucleus. The neutrons can be calculated by taking the mass and subtracting the atomic number. Remember to round the mass before you do your subtraction. The number of electrons is normally the same as the number of protons, which is also the atomic number. Of course, electrons in real life can move around and sometimes jump from one atom to another. So the number of electrons can change, but if the atom was neutral or balanced, it would be exactly the same as the atomic number. Let's take a look at our work here. You've got a scavenger hunt, which is pretty self-explanatory, but let me go through the atoms family math challenge. So why don't we fill in some of the things that we need to know, like 8 represents the atomic number, which is the number of protons or electrons. The symbol for oxygen is O. We always use a capital letter for the symbol, and if the symbol has 2 letters, capital first, the second letter is always lowercase. Finally, we have the mass. For most of our math, we're going to have to round that to a whole number. In that case, we'd have 16. Let's look at one of them a little more closely. What do we have to do? Let's fill in all the blanks for the things that are missing. For some of these, you might want to use a periodic table of your own, but I know that silicon's symbol is capital S, small I. The rest of this I can figure out right from what we've been given. The atomic number is 14. The atomic mass, and we want to round that, will be 28. The number of protons is the same as the atomic number. That is 14. To get neutrons, we subtract the mass minus the protons. In this case, another 14. And the electrons, being negative, have to balance with the positives, so again, a 14. For each of these elements, please go ahead and fill out all the missing parts on these. And hopefully you guys enjoyed your lesson on the periodic table. Thanks again so much for coming and stopping in, and hope you're doing well. If you have any questions, go back and look at this video again, or shoot me a message. So thanks again for coming by, and we'll see you next time.